Hello, this is Walter Leite, and in this video, I will show you how to evaluate the exact fit of a structural equation model and compare alternative models. We're going to be using the path analysis model of this article, and the model is this model here. So we'll first fit this model in Amos. So I will start by showing the data set. So select data file, file name, and this is the file name here. And it's the correlation matrix is standard deviations provided by the author. So it's not raw data in this case. I'll click view data, and it's an Excel file that has this specific format here with sample size in the first row, and then standard deviations, and then the lower correlation matrix. So the data read correctly. I can close this, I can click OK. Now that I have the data declared, I can click on list variables in the data set, and I have all the variables here and can build my model. The model has mother behavior, child behavior, and adolescent behavior, as well as education and SES, which is family income. And 5 variables. And then the paths are from mother behavior to adolescent behavior, from mother behavior to child behavior, and then to adolescent behavior. So child behavior here is a mediator. From education to child behavior, adolescent behavior, and from SES to child behavior, and adolescent behavior. Now, the 3 exogenous variables should be allowed to correlate. The authors don't show these correlations in their model in the paper, but they were there. So I will add these correlations here between the exogenous variables. And that gives us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 correlations. So this model is saturated because there are 10 paths being estimated here. Now, if I look at view data, so I data file view data, there are 10 correlations here, this lower diagonal matrix. So there are 10 correlations between the variables of interest. I can calculate this by just doing number of variables times number of variables minus 1 divided by 2. So I have 5 variables times 4 divided by 2. There are 10 correlations in between these variables in the data set, and I'm estimating 10 paths here, which gives a degrees of freedom of 0. So this model, a model with degrees of freedom of 0, is a saturated model. Therefore, it will fit the data perfectly. So I can't really evaluate the model fit for this model. So it's not ideal to use saturated models because they're not parsimonious and you cannot know if they fit. But we'll start with a saturated model, then try to simplify to a more parsimonious model. Now, this is not ready because I still need to add measurement errors to child behavior, adolescent behavior, because they are endogenous variables being predicted like by other variables. So I'll click here and add the measurement error here and the measurement error here. Measurement errors are latent variables. And I also need to click on the hand and give names to these errors. I'll call this E1. And I'll call this one, I double clicked, E2. Okay. And I'll use the move tool here. No, the select move tool, which is the little fire truck to move these errors back here and just to get it out of the way. And I'll use the touch up tool to embellish things a little bit. Okay, this looks better. Now I'll save Stella path analysis. And I'll ask for analysis properties before I run, which is this. And I'll feed this with maximum likelihood, which is the most common estimator for structural equation modeling with continuous variables. And it's a syntactically unbiased, it's efficient, and it requires a smaller sample size than all the ones here. And then for output, I want the standardized estimates as well. Close this, save again, then I can click calculate estimates. So I know it converged because it shows here minimization, iterations, and the chi-square. Chi-square is 0 because the model is saturated, and the degrees of freedom is 0, right? Showing. So to be able to, here I have unstandardized estimates, and here I have standardized estimates. But before I can interpret the estimates, I need to check the fit of the model. In this video, I'll look at exact fit, and I'll do a different video for close fit. We should always look at both exact fit and close fit when you're evaluating a structural equation model. So the chi-square is a measure of exact fit, meaning that the model fits the covariance matrix exactly. The chi-square test compares your model of interest with the saturated model. Now here, the model of interest is a saturated model, and that's why the chi-square is 0. So to see the details, click here on View Text, and it shows chi-square 0, degrees of freedom of 0. And then the model fit, we are only interested in the first table here, which is the chi-square. Default model is your model of interest, which has a chi-square of 0 here. The saturated model, chi-square of 0, which is also the model of interest here. And the independence model is the worst fitting model. It's basically a model that says that all the 5 variables we have are uncorrelated. So you would delete all the paths to fit that model. And that's used later to evaluate close fit. But here you see the chi-square is very large. The worst fitting model has 10 degrees of freedom. Has terrible fit. Okay, so now we will fit an alternative model that's not saturated. I'll close this, and I will delete. I'll click here on View Input. I will delete the direct effect between mother behavior problems and adolescent behavior problems. In other words, I will make that fully mediated by child behavior problems. So click on the X, delete. Now this model has 1 degree of freedom. It's a little bit more parsimonious than the previous one. I'll save, and I'll calculate estimates. So it shows here the degrees of freedom, chi-square shows the chi-square of 0.4, degrees of freedom of 1. Okay, let's look at the text. With this probability level, this is the chi-square test, and it's comparing the saturated model with a model with 1 degree of freedom, which is our current model. And you know, the saturated model has perfect fit. You want the current model to fit as well as the saturated model. Therefore, we we want a chi-square test that's not statistically significant, because not statistically significant chi-square test shows that there is no difference between the current model and the saturated model. So here the p-value is 0.516. So if you're using an alpha level of 0.05, any p-value equal or greater than 0.05 indicates that's not statistically significant. So this is 0.516, it's not statistically significant. So this model fits as well as a saturated model, and that means it has exact fit. Okay, we can look at more details when you click here on model fit. The first table shows the current model, degrees of freedom 1, saturated model has degrees of freedom 0, the p-value is 0.422. His model has exact fit. Now let's simplify the model even more. Okay, so for the next model, so we fit these, we fit one without the direct effect. Now we will fit another alternative model where we will delete two paths. So now mother's education and family income will not have any effects on child behavior problems, only on adolescent behavior problems. So that's even a simpler model. Going back to Amos, I will click here to see the model. I'll click on X and delete these two paths. Oops. Missed, it has to be red. Okay. Now this model has this model has a degrees of freedom of 3 because now I deleted 3 paths. I'll save and I'll calculate estimates. And you can see here degrees of freedom of 3, the chi-square is 5.6. Now let's check if this model has exact fit or not. I'll click on view text. Now we can see chi-square is 5.624, degrees of freedom of 3. This model still has exact fit because the probability level is not significant. Okay, so now we will do another so we'll try another model where that's even more simplified to check if we can get a model that doesn't have exact fit. I'll close this. I'll go back to the model and I will add this path here. And I will delete this. So now the effect of education in SAS goes to child behavior, and then it's mediated by child behavior. It has an indirect effect on adolescent behavior. So this model also has 3 degrees of freedom. I just switched which paths were free or fixed. I'll save and run. Oops. Save again. So you can see chi-squared is 18.3, degrees of freedom is 3. Let's look at the at the detailed test. So this model, now the chi-square is 18.26. Probability level, which is the p-value, is 0.000. It's a very small value that got truncated, so it's less than 0.05. So this model fits significantly worse than the saturated model. So this model doesn't have exact fit.